Hey, hello everyone. This is the second part of the object-oriented programming tutorial, but this focuses more on why object-oriented programming in deep learning specifically. So in general, we recommend object-oriented programming because it enhances code reusability across various projects. So when you're using object-oriented programming, you're basically containing classes that are like self-contained modules. And so they can be reused across different projects or like parts of the same, or even in the same project. So for example, let's say you're using a generic neural network layer class, and you can like keep reusing that layer class across the whole project to build different models. And secondly, it makes sure to keep the code clean and reduces overlap, especially object-oriented programming. It allows you to encapsulate the data and methods within the class. So it protects like the internal state of objects and reduces the risk of like unintended behavior or like interaction. And then also it enables easy modifications and additions to models. So when do you use object-oriented programming in deep learning? Well, as much as you can. There is pretty much like if you think it's just let's say you have like a different stages in the model pipeline, like you're loading the data sets, you're forming data batches, you can have a data loader class. So that data loader class can, for instance, take care of, let's say, pre-processing steps and reading from data files and so on. And then you'd also realize if you're using like similar type of data, like across, let's say, different homeworks for projects, you wouldn't need to change this step of the pipeline, and you can just reuse this data loader class. And we'll talk about it later, but like you can also define different parameters. So it makes your data loader class a bit more flexible. And so it enhances the code reusability. And then secondly, let's say you're designing and defining a deep learning model. So a model class where you can have different attributes such as the different layers and so on. And then also you can also have different classes for training, model training part, testing part, evaluation process, and so on. So let's go over some toy examples to better understand that. So we have a simple data loader class here, and we have a method called get batches. So let's say we have a model and it expects like the data in form of batches instead of like the actual data. So we want to have a class that will take our data as it is and return the data in forms of batches. So we have the init constructor that was already covered in the previous part of the recitation. So this is the get batches method that we defined. So what it's going to take is that it's going to loop through the data, and depending on the batch size that we're gonna, it's going to skip based on over that. Like it's going to skip based on that. So we have a dummy data set here, and then we print the full data, and you have 20 numbers. And then we're instantiating the data loader class with the data set and a batch size. So here we're initializing the batch size to be 10. And so you can see it goes over our first batch. It's going to go over the whole range until the batch size of 10. And then also for batch size for the second one, where it starts from 11 and goes all the way till 20. Okay, now going over the simple model. Let's say we have a model class and we want to define that. In the model class, we have an init constructor, and usually over there, you would define the different type of transformations that you want your model to handle, basically. So here, let's say we have the forward method, which is the most important method. And you realize like in a lot of model classes, we always have a forward and a backward method. So what a forward usually does is it takes your input data that you have and it puts it through the different transformations that you've defined in the init class in the order that you would want it to be. So for instance, we initialize the model here. And then this is our input data 20. So what it's going to do is I call my class model. And in that model, I'm calling the method forward. And I'm giving it the input data 20. So it's going to take the data 20 and it's going to come here, which is my initial data. And it's going to do self-transformation 1. And my first transformation is multiplying by 2. It's going to multiply this by 2. And then I'm going to give this input, which is transform data, which is currently going to be 20 times 2, so 40. So it's going to give 40 to my transformation 2. And my transformation 2, it adds 2 to that. And then it will initialize this, which is 42. And then here, it's going to go back again. And then my end result is dividing by 2. So once we run this, our output is 21 as expected. And so why the whole class thing, you can see it's so helpful because if I had a different input data, all I need to do is change the input data here. So let's say we're using 10. I would not need to redefine anything over and over again. And it's so helpful. So, but let's say if you want it to be a bit more flexible in terms of, let's say you want to have different transformations and you don't want to keep changing it, you can also add more parameters. So instead of having predefined transformations, you can make them be parameters of the class. So here I have a parameter for multiply, parameter for add, for parameter for divide. And depending on that, I can be like, okay, I want to multiply with this, I want to multiply with that, and all of that. So that's a bit more flexibility and so on. And then in the end, we have some questions for you to go over to make sure that you've understood the main gist of the object-oriented programming. And if you guys still have more questions, feel free to reach out on Piazza. Yeah, that's all from our side. Thank you.